Hello. Welcome back to my YouTube channel. This is Rishi. I have been away for quite some time, but here I am, and it's time to continue from where we left off. So for matrix, we have covered the basics and about multiplication. Now it's time to dive into the next part, which is the identity matrix. Without any further ado, let's begin. As for identity matrix, it's relatively a simpler topic compared to the other parts of this chapter. But although it's simple, it is one of the most important thing you need to understand very well in order to move on to the next part, the inverse matrix. So be sure to pay attention. Identity matrix is essentially, in layman terms, the one of integer. By one, I mean, if you take a matrix, any matrix, and multiply them by this identity matrix, you will get the matrix itself again. For example, A times identity matrix will equal to A again. So essentially, it is the number 1. I'm pretty sure you have seen this particular formula in your textbooks. This equation means the exact same thing. You have the identity matrix, multiply it by any matrix, you will get back A. And by the way, I times A and A times A are the same thing. So they're just showing you different possibilities. So now that we know what an identity matrix is, let's take a look at how to represent an identity matrix. Identity matrix, such a difficult word to say. Alright, please don't roast my pronunciation. I'm trying my best. Alright, so how does it look like? So first off, the first condition will be it has to be a square matrix. It can't be a rectangular matrix, it has to be square. And the positioning of the number, it has a certain pattern to it. The moment I show it, you will understand. Let me write it down for you first. Let's use dark green. One, 0, 0. This is how it looks when it is 2 times 2. Let me show you how it looks like when it's 3 times 3. And as the final cherry on top, let me show you 4 times 4. It has lots and lots of zeros. So if you take a look at this, you can see that there is a particular pattern, especially with the number 1. The number 1 is arranged diagonally from the top left to the bottom right. And it repeats for any arrangement of matrix. No matter it's 3 times 3, 4 times 4, even if it is 15 times 15, or if you want to go bigger, 100 times 100, it is still going to look the same. For an identity matrix, the number 1 has to be arranged from the top left to the bottom right. And if you're wondering whether it's only 1, yes. In the Form 5 syllabus, it's only 1. And I'm not sure about advanced levels, but I'm pretty sure that as far as SPM goes, it has to be 1 from the top left till the bottom right. And now, I know that some of you might be asking me, you said it's essentially 1, but how can I believe you? First off, please believe me. And second off, let me prove it to you. So let's take a matrix. Let's say, this is a random one. Let's say 2, 4, 3, 6. And then we multiply this by a square identity matrix. Let's say, oh, it has to be 1, 1, 0, 0. Right. So for this kind of equation, we know for a fact that we have to get back 2, 4, 3, and 6. If we don't get this back again, it means that I have made a mistake in the calculation, but let's hope that that doesn't happen. Right, let's see. So if you have not watched my video on how to multiply the matrices, it's here. It's like an overview of it, but I would advise you to take a look at my another video where I explained how to multiply in detail. Okay, so I will skip this part. Let me show you how I multiply this. So we have 2, need some space. Let's put 2 here, 3, 4, and 6. Then 1, 1, 0, 0. Matrix here and a matrix here. Use the orange color. Right, 1 here, 1 here. Right, this should do it. Let's see. 2 times 1 and 4 times 0. Then we have to add these two together. If this is confusing for you, please take a look at the other video. I've explained in great detail in that particular video. And so we have 2 plus 0, we get 2. Very good. I'm spoiled for choices here. Too many options. So let's go with 2. And then for the next one, it is going to be 3 times 1 and 6 times 0. 3 times 1 is 3, 6 times 0 is 0. So 3 plus 0, we get 3. And then the same thing repeats for the other two. 2 times 0 is 0, 4 times 1 is 4. 4 plus 0, we get 4. And finally, 0 times 3, which is 0, and 1 times 6, which is 6. 6 plus 0, we get 6. And there we go. And as you can see, the answer that we get is 2, 4, 3, 6, which is the exact same as the matrix that we used earlier. These two are equal to each other. That's why I said that an identity matrix is essentially a 1 in terms of matrix. It is crucial to understand this chapter, as we will be using this concept together with the concept of inverse to do more in the next video. So with that, this video comes to an end, and I hope you learned something. If you face any difficulties in understanding, or if you would like to ask any questions to me, please take a look at the description for my email address, and I will be addressing your questions there. With that, thank you very much, and I will see you in the next one. Bye-bye.